Hi guys! ACI has become a large ecosystem which includes lots of functions and features, and it is constantly evolving. In order to get maximum value out of it or decide to start your SDN journey with ACI, you should be aware of its capabilities, architecture and philosophy. In this video I will try to answer the most common and the most important questions about ACI. The purpose of this video is to give you a comprehensive overview of ACI, explain to you what ACI is, how ACI operates and how it solves challenges in data center environments. I will not dive into all technical details, but by the end of this video you should have just enough knowledge to be able to find all the information you may need and answer any questions you may have. With that being said, let's start with agenda. I will cover the following topics: business perspective of ACI solution, architecture and components, deployment of ACI, fabric policies, tenant policies, fabric forwarding, external connectivity, virtualization integrations, service insertions, dealing with multiple data centers, public clouds, programmability of ACI, security in ACI, complementary products, troubleshooting and migration scenarios. In order to keep this video at reasonable length, I will dedicate 2 slides for each topic. One with most popular and important questions, and second with some theory, diagrams and other information. So let's start with business perspective. Our question here is, why do I need ACI? ACI is a comprehensive solution for managing all your data center networking from a single pane of glass in an automated and programmable manner. Its simplicity allows you to reduce operational expenses spent on maintaining and operating your DC network. Because of its automated nature, highly available architecture and rock-solid protocols, it significantly increases availability of applications that you run on top of your network infrastructure. ACI leverages best-of-breed technologies in the industry, as well as Cisco unique features. It results in increased performance and agility. Also, it allows to scale the whole system to an immense size. ACI supports both disaster recovery and active scenarios if you have multiple data centers. ACI has been built with security in mind. It leverages zero trust or whitelist model and allows you to apply consistent security policy everywhere, for your bare metal endpoints, for your virtual machines, for your microservices, and even extended to a public cloud like AWS. There are many different use cases for ACI, and if you do have data center, you can easily understand how it can be applied in your environment. Now let's jump to the next section. Questions here are: what is ACI architecture and what components form ACI? ACI has 3 main components: spine switches, which you can see on the top, leaf switches in the middle, and cluster of AP controllers. Other elements that augment ACI will be discussed later. AP controllers are responsible for representing all your switches as a single fabric, and they allow you to manage this fabric from a single pane of glass. When you want to get a particular result, for example, allow communication between VM with web server and VM with database, you just need to construct your intent and deliver it to APIC. APIC will distribute that intent across the fabric, and nodes, switches, will transform that intent into configuration and apply it. One key point here: APIC doesn't handle data plane traffic and it never lies in the data path. Next piece is leaf switches. These guys do all heavy lifting. They accommodate all your endpoints, bare metal servers, hypervisors, other network service devices like firewalls or load balancers. They are also responsible for communication with external network, legacy data center network, campus network, wait area network, the internet. Almost all sophisticated logic like security policies or policy-based redirect is applied at leaf level. And final component is spine switches. Typically, they are modular switches with huge number of line cards and high-speed interfaces. Their main goal is to provide very basic but lightning-fast connectivity between leaf switches inside your fabric. But they also keep kube database, which in turn keeps information about all endpoints in your fabric. Also, they act as BGP route reflectors, and they play a key role when you want to interconnect multiple data centers. For example, if you leverage multipod or multi-site topologies. Basically, you can compare ACI with a regular modular switch or router. Epic is analogous to supervisor. Leaves are line cards, and spines are fabric modules which interconnect all these components. There are some rules which dictate how ACI components should be connected to each other. There are no connections between leaves, there are no connections between spines. Each leaf is connected to every spine directly. All endpoints and external devices are connected to leaf switches. But as always, we have some exceptions. For example, we do connect external devices directly to spines when we do multipod or multisite. More on it later. Now when we know all key components, let's discuss how we actually deploy ACI. Deployment of ACI is a fully automated process which requires minimum human interaction. ACI leverages automated fabric discovery and also automated underlay and overlay configuration. Practically, it means that you need to rack and stack your equipment, provide basic information for initialization script, and acknowledge fabric nodes. If you have many fabric nodes, you can automate this process and just feed ACI with a spreadsheet of your switches, and it will acknowledge them automatically. Anyway, when you are finished with these very simple steps, you have complete the excellent fabric up and running. Everything related to underlay network, which is transport network, and overlay network, which is network for actual endpoints traffic, is already configured and just waiting for endpoints to become connected to the fabric. So let's talk about configuring interfaces in ACI. Fabric policies allow you to treat your whole fabric as a single giant switch and encourage you to leverage reusable constructs or templates. If you have lots of endpoints connected in exactly the same manner, you can create a single policy representing that connection. For example, LLDP enabled, 10 gigabit port connection, BPDU filter on, and apply it to all corresponding ports throughout the whole fabric. You can see this example on the diagram on the right. So here we have our policy. And this policy is applied to different leaf switches on different ports. If all these ports are basically the same in terms of connectivity parameters, you can apply the same policy to all of them. Fabric policies define most of physical and logical connectivity parameters which when you connect endpoints, services, or external network. Although there are many configuration settings in this section, fabric policies do not define final encapsulation on the wire. It means that they do not define which .1q tag your leaf switch will put inside Ethernet header before sending it to your hypervisor, for example. And they do not define switching or routing logic. For example, they do not define OSPF or BGP route peering to your external networks. Those parameters and protocols are configured under tenant policies, which I will explain on the next slide. So here we have lots of questions. How do I establish routing or switching between ACI and other networks like legacy data center network, campus network, wait area network, the internet? Or how do I configure switch port access VLAN 10 on switch X and port Y? How do I configure SVI for endpoints connected to ACI? Or how do I implement ACL between endpoints? These questions represent a small part of what tenant policies actually do. I would say that most of your day-to-day tasks are related to tenant policies. This is what you most likely touch when you need to change something or add some new functionality. At first, let's define tenant. ACI is a multi-tenant solution. Basically, it means that you can secure share physical resources of your fabric amongst multiple different entities. If you are a cloud service provider, you can use ACI to completely separate your customers but still connect them to a single physical fabric. So you can see right here we have customer A and customer B. They are connected physically to the same physical fabric, but they are completely separated. In enterprise environment, you can use different tenants for different departments like IT, HR, and accounting if they require strict networking separation. Also, you can leverage them to separate software development life cycles like development, dev, test, and prod, where prod stands for production. By default, tenants are completely separate from networking perspective, but if you need to configure some type of communication between them, it is also possible. Tenant is a logical container and it accommodates other elements like VRFs, bridge domains, subnets, application profiles, EPGs, contracts, and many more. It is depicted right here. Its hierarchy. VRFs, bridge domains, and subnets are networking components, and they are responsible for bridging and routing logic in the overlay. Application profiles and EPGs are responsible for making your infrastructure application-centric. Remember, ACI stands for application-centric infrastructure. You use these constructs to group your endpoints in logical groups like clients, web servers, databases, etc. After grouping, you leverage contracts. This is a contract and this is also a contract. So after grouping, you leverage contracts to define security policies. Contracts are similar to ACLs, access control lists. At the bottom you can see an example which represents typical web application. It consists of a database, web server, and actual clients, which access and use that app. In ACI, all these logical groups are represented as EPGs, or endpoint group. And contracts, as I mentioned before, define communication types allowed between them. So we have contract between EPG clients and EPG web. Let me clear that. So we have a contract between EPG clients and EPG web, and this contract defines which communication is allowed between those EPGs. And the same story here, we have another contract between EPG web and EPG database, and basically it defines which traffic is allowed between web servers and MySQL database servers. Other elements like L3 outs and service graphs we will touch later. Now let's move forward. This slide should help you answer questions like what control plane does ACI leverage, or what exactly happens to my frame during its trip through the ACI fabric. ACI uses a range of control plane and data plane protocols like ISIS, VXLAN, COOP, multi-protocol BGP, and others. Also, it implements optimization features like using hardware proxy, for unknown unicast, direct IRP forwarding, bounce entries to support endpoint migration, silent host handling, distributed anycast default gateway, to name just a few. ACI isn't classic BGP EVPN fabric, but the general idea is very similar. So if you want to understand ACI forwarding in detail, I would recommend you to start with BGP EVPN and then fill the knowledge gap between EVPN and ACI. Without strong knowledge of VPN, it would be pretty difficult to understand what happens in ACI behind the scenes. Also, there is a very important topic in ACI which relates to VLANs. ACI uses lots of different VLAN types like platform-independent VLAN, hardware VLAN, encapsulation VLAN, etc. In order to troubleshoot ACI, it is very important to understand how those VLANs are tied together and what they actually do. And on the right side of this slide, you can actually see an example of a frame which goes through the fabric. I will not go through technical details right now. It is just an example which you can see, which you can learn at your spare time. Now let's discuss how ACI connects to external networks. So how do I connect external networks to ACI? ACI is just a part of your IT infrastructure, so it must be connected to other pieces of your network like legacy data center infrastructure, wide area network, campus, and the internet. ACI can extend both Layer 2 and Layer 3 domains. Layer 2 domains can be extended by stretching EPGs or by stretching bridge domains. First case is pretty simple in terms of configuration, but second requires creation of a construct called L2out. As you may have guessed, this construct is a part of Tenant Policies. In order to extend Layer 3 domain, you can leverage Layer 3 out construct with routing protocols like BGP, OSPF, and EHRP, or with static routes. Again, L3 out is a part of Tenant Policies. When you have too many L3 outs, it may happen if you are a CSP, cloud service provider. Then you have lots of customers, each with his own tenant and respective L3 out. You may want to leverage another approach, which is called Golf. G-O-L-F. Golf allows you to establish single peering session for multiple tenants instead of one L3 out per tenant approach. Also, Golf is an example of exception rule in terms of ACI connectivity. When you are doing Golf, you connect external routers directly to spine switches. So, if you leverage Golf, you have your external routers and you connect them directly to your spine switches. In other cases, as you can see, you connect your external networks, legacy, campus, WAN, internet to your leaf switches. And those leaf switches are typically called border leaf switches. Okay, now let's talk about interaction between ACI and virtualization platforms. So how does ACI interact with virtualization platforms? One of the key benefits of ACI is its wide range of integrations, especially with infrastructure components you almost certainly have. You can connect ACI to your VMware vSphere, Microsoft Hyper-V, and OpenStack. If you are an avid fan of microservices and containers, you can integrate ACI with Kubernetes and OpenShift. Here are named just most popular integrations. If you use something else as your virtualization platform, you should definitely try to research whether ACI has an integration with it. In case with VMware, ACI leverages a connection between APIC and vCenter. By the way, APIC and vCenter share some remarkable similarities. APIC manages switches which handle all the data plane, and APIC itself doesn't lie in a forwarding path. vCenter manages hypervisors which accommodate VMs and actually do all the computing stuff. vCenter itself doesn't run any of your VMs. In this integration, APIC dynamically creates and configures networking elements inside vSphere, like VDS, which stands for Virtual Distributed Switch, and port groups. VMware administrator only needs to assign VMs to correct port groups. So here we typically have VMs, and when you leverage that kind of integration from a VMware side, you just need to assign this VM to correct port group. That's all you have to do from VMware side. Creation of these port groups is triggered when you configure or when you instantiate corresponding elements inside ACI. So typically you create EPG, you associate it with virtual machine manager, and it triggers creation of port groups. After that, you assign your virtual machine to that port group, as I mentioned before, and you are good to go. Actually, it isn't the only integration between VMware and ACI. You can also leverage vCenter plugin, vCenter plug-in for ACI, which allows VMware admins to configure ACI elements from vCenter user interface. Now let's jump to our next topic and Question for this topic is how do I insert firewall or load balancers in ACI? ACI allows you to add network services like firewalls, load balancers, IPSs and IDSs, DPI devices and other boxes in a very flexible manner. You can do that in an old-fashioned way with various stitching or sandwiching technologies, or you can implement policy-based redirect. This particular feature allows you to redirect only specific type of traffic to the firewall or any other box. For example, you may want to inspect only HTTP traffic between EPGs and leave replication or any other traffic outside in order to save firewall resources. You can do that with PBR. You can also change services like on the figure at the bottom of the screen. You can put a load balancer between clients and web servers and firewall between web servers and databases. From location standpoint, your services can be placed on any leaf switches. You don't have to keep them on the same leaf with your endpoint or something like that. Here you can see that endpoints and firewalls are located behind different leaves. Also, I need to mention that there are different levels of interaction with network services devices. You can attach them manually, you only configure ACI constructs in APIC, and firewall is configured separately via its native management tool. You can configure ACI constructs and also configure firewall's networking towards ACI in the APIC. It means that APIC will connect to this firewall and configure networking part in it. And finally, you can configure firewall completely from the APIC. It means that you will configure everything in APIC. ACI fabric, firewalls networking towards ACI, and also firewall rules, for example, how to inspect traffic. Now let's move forward. And here I will tell you how to build multiple data centers with ACI. There are different approaches for deploying ACI in multiple locations. Two major options are multi-pod and multi-site. Both options mean that you need a set of spine and leaf switches at each location. And these locations are interconnected via spines and IPN for multi-pod and ISN for multi-site. IPN stands for inter-pod network and ISN stands for inter-site network. Differences start with APIC clusters. In multi-pod, single cluster manages all your fabric. So typically you will have two APICs at one site and a third APIC at the second site. It means that from management standpoint and policy standpoint, you still have a single domain because these APICs belong to a single cluster. Every configuration you make will be applied in both locations, here and here. Also, it implies some specific API cluster design to avoid split brain scenarios and loss of data. So this is exactly what I show you. Here we have two APICs on the left side and one APIC on the right side to avoid split brain scenarios and loss of data, as I've just said. And your IPN network must satisfy some requirements like multicast routing, MTU size, DHCP relay, and some other things. In multi-site, it is a little bit different. In multi-site, you have a separate APIC cluster at each site. So you have APIC cluster here, and APIC cluster here. In multi-site, separate API cluster at each site. So in multi-site we have separate API cluster in each site, and those clusters are interconnected between them through a new component which is called multi-site orchestrator, or MSO. And MSO connects those AP clusters from control plane standpoint. It allows you to separate policy domain. Only changes that you really want and need will be propagated to selected sites, sites which you explicitly select. Also, ISN requirements, inter-site network requirements, are much more easy to satisfy. It could be just generic layer 3 routed network. And now we seamlessly arrive to extending ACI to locations where we can't afford to place the whole fabric or where we do not have any physical equipment at all. So, how can I extend ACI to public clouds? You can do that with AWS, Microsoft Azure and Google Cloud Platform. In case with AWS, you will actually spin up a Cloud APIC instance inside AWS, which will be responsible for mapping ACI policies to AWS native networking and security constructs like VPC. In Amazon, it stands for Virtual Private Cloud, security groups, and others. Also, you will need CSR router here to establish data plane connectivity between AWS and your ACI fabric on premises. If you have a small location and it isn't feasible to install a complete ACI fabric there, you can leverage remote leaf feature. It allows you to put a leaf switch in such location and connect it over layer 3 network to your main fabric on premises. If you don't have physical environment at all, you can use virtual pod feature, which consists of virtual leaf and virtual spine switches which run as virtual machines. Now let's discuss automation in ACI. So how do I automate ACI? ACI can be configured and automated using different tools. At first, you need to know that everything you do in a graphical user interface leverages API and can be easily automated. To do that, you can leverage different tools with different levels of granularity. You can use Python scripts, and do pretty much everything you want with Python scripts, or you can try more simpler and abstracted solutions like Postman, for example. You can leverage software development kit like Cobra. You can use Ansible. You can integrate ACI with Cloud Center, UCS Director, and VMware vRealize Orchestrator. Overall topology for all these use cases are pretty similar. You have some entity which does automation. Here, it can be Ansible control machine or Cisco Cloud Center component. This entity talks to APIC in a programmatic way, and finally APIC configures the fabric. Use cases for automation are countless. You can configure, troubleshoot, and operate ACI more easily using scripts or orchestrators. Programmable nature of ACI also explains why it has so many integrations which are impossible in legacy environments, which are managed in a device-by-device manner using CLI. Now let's talk about security in ACI. So how does ACI implement security? The key thing here is that ACI is built with zero trust or whitelist model. It means that by default no traffic is allowed between different EPGs without a contract. Of course, you can disable or work around this behavior, but ACI really encourages you to start implementing whitelist security model. The simplest definition of this model is that everything is blocked if it is not allowed explicitly. But in order to deploy that model, you need to know how all endpoints inside your data center are talking to each other and to the external world. This problem is solved by integration with Cisco Situation Analytics product. Another security specific feature is integration with ICE. In a nutshell, it allows you to map your SGTs, security group tags, from ICE to EPGs in ACI. And actually you can do vice versa, which allows you to have consistent policy across your data center and the rest of your network. Also, ACI leverages MACsec encryption for local layer 2 encryption at line rate and CloudSec encryption for inter-site data encryption. And finally, ACI provides extensive role-based access control functionality. And since I have mentioned integrations with other Cisco products, let's discuss it a bit deeper. I have already covered integration with Tetration Analytics, but we still have others. Network Assurance Engine analyzes your configuration, points you to potential problems in your configuration, and tells you how to fix them. It helps in troubleshooting, cleaning up stale configuration, and compliance. Cisco Cloud Center allows you to model your application and automatically deploy it in your cloud or on your cloud, be it on-premises cloud like VMware vSphere or public cloud like AWS. In our case with ACI, it allows you to provision all network infrastructure in few clicks thanks to integration between Cloud Center Orchestrator and APIC. UCS Director also has been mentioned before, so I'll just repeat that it can help you automating ACI procedures. Integrations with other key Cisco solutions like DNA and SD-WAN are also on their way. Now let's go to the next slide. And our question here is, how do I troubleshoot ACI? There are many tools for troubleshooting. At first you have graphical user interface. It provides you with very descriptive faults mechanism which allows you to drill down to the root of your issue. Also it has a tool called Visor or Visori, sorry for my pronunciation, which allows you to navigate through the API tree. CLI has lots of show commands at both APIC and switch levels. In addition, it has tools like MO query, curl to leverage API from CLI session. So basically you can initiate a CLI session with your APIC, and from that session you can still make some queries to API. So if you are logged in your APIC and you are making MO query, so basically you are making a query to yourself, to the same APIC you are logged into. Also we have some classic troubleshooting tools like ping, which is called iping, and TCP dump. And also we have a tool called ELAM, which can help you if you need to capture a specific frame in your fabric. And obviously you can leverage API to troubleshoot your network in a programmable way. Let's move forward. Question for this section is, how do I migrate to ACI? There are at least two migration areas. First one describes how you move your endpoints from your legacy data center network to ACI. Typically you do that in the following manner. You establish layer 2 connectivity between ACI and legacy network and start moving endpoints to ACI. When you reach some threshold, number of endpoints in ACI versus number of endpoints in legacy network, or number of critical services in ACI versus legacy network, you move default gateway from legacy network to ACI and advertise that particular subnet over layer 3 peering. Other type of migration is related to network-centric mode versus application-centric mode. Here you can see graphical representation of both of them. In network-centric mode, EPG is equal to your legacy VLAN and IP subnet. In application-centric mode, your EPG represents logical grouping, like database servers, for example, or web servers, or external clients. I need to stress out that there is no knob in ACI to switch between these modes. So you can say to your ACI, please run in application-centric mode, or please run in network-centric mode. You can have some part of your network being configured in network-centric mode and other part in application-centric mode, and they will work and interoperate just fine. These models are just approaches that you may use. And as I mentioned earlier, in order to migrate to application-centric mode, you need to understand all interconnections between endpoints. For example, web server talks to database servers over TCP 3306, and web clients talk to web servers over TCP/80 and 444.3. Tools like Troubleshooting can help you build these so-called application dependency mappings. And finally, our last slide for today, but definitely not least. So how do I do X with ACI? Probably at the time you are watching this video, ACI has already been updated and has some new cool features. So in order to keep up with all new things and in order to deepen your knowledge on all the topics I have discussed in this video, I encourage you to go to ciscolive.com. So here, let me switch to my browser. And here we are at ciscolive.com. Now let's go to on-demand library. And here we need to search for BRK ACI. And here you can actually see 216 different sessions. So for example, how to set up an ACI fabric from scratch, ACI multi-site architecture, Cisco ACI multi-pod design, end-to-end data center security architecture, Cisco container networking solutions, ACI and OpenStack, ACI multi-pod, ACI for VMware admins, ACI troubleshooting, ACI virtual pod, automating ACI, Cisco App Center. So I guess you understand the idea. So as I said, ciscolive.com, on-demand library, and search for BRK ACI. So there you can find all new features, and also there you can find everything that I've mentioned in this video. So if you want to deepen your knowledge, if you want to know exactly how, for example, fabric forwarding works, how to integrate ACI with Kubernetes, you can definitely find some session at Cisco Live. So this part concludes this video. Thank you all for watching. If you like it, please put your thumbs up and subscribe to my channel. See you!